Learning to code, it can be a really humbling experience. You've been there, right? You follow all the rules, you check your logic a dozen times, and still your code just flat out refuses to work? But what if I told you that all those frustrating moments, they're not failures? They're actually the secret to becoming a truly great developer? Man, Oscar Wilde just hit the nail on the head with this one. In the world of programming, your experience isn't really measured by the perfect code you write on your first go. No way. It's built on that huge mountain of errors that you've already climbed and conquered. Every single bug is a lesson.
Okay, so let's really get into this, because this is the big question. Getting a program to run without crashing, that's just step one. The real journey, the one we're all on, is about moving from simple functionality to real quality. It's about going from being just a coder to being an engineer.
Look, every developer, and I mean every developer, has been brought to their knees by something as silly as a missing semicolon or some totally cryptic error message. The real difference between someone who throws in the towel and someone who succeeds, it's learning to see those errors not as walls, but as clues. Debugging isn't just a skill you learn, it's a whole mindset.
All right, so every journey has a starting point. For a developer, that means getting fluent in the basic language of the machine, which, you guessed it, also means learning the 3 main ways you can get it wrong right at the beginning.
So first up, you've got your syntactic errors. This is basically the code equivalent of bad grammar or a spelling mistake. If you forget a comma or a semicolon, the compiler just throws its hands up. It literally cannot figure out what you're trying to say. The good news? These are usually the easiest bugs to fix because your tools are great at pointing right at them and yelling, "Hey, fix this." Next on the list are semantic errors. Now, with these, your grammar is perfect, but the sentence you wrote is total nonsense. It's kind of like saying, "The sleepy rock sang a beautiful song." Grammatically, fine, but logically, it means nothing. A classic example in code is trying to use a variable before you've actually given it a value. The syntax is fine, but the meaning, the semantics, is just broken.
And that brings us to the sneakiest of these early errors, logical errors. Oh, these are tricky. The program runs perfectly, no crashes, no error messages, but it gives you the wrong answer. This is that classic situation where the computer did exactly what you told it to do, but what you told it to do was wrong. These can drive you nuts.
And right here, this is one of the most common beginner traps that leads to those logical errors. A single equal sign is a command. It tells the program, hey, make x equal to 5. But a double equal sign, that's a question. It asks the program, hey, is x equal to 5? Mixing these two up won't always crash your code, but I guarantee it will cause some super confusing bugs down the road.
So, you did it. You've conquered the basic errors. Your code runs, it gives the right answers, you're feeling good. But guess what? The journey is just getting started. Now we get to enter the world of hidden traps, where code that works can still be really, really bad code. And this is where we have to talk about something called anti-patterns. You can think of these as tempting shortcuts or solutions that seem really clever at the time, but they end up creating an absolute maintenance nightmare for you or, let's be honest, for the next developer who has to look at your code.
A perfect example of an anti-pattern is the magic number. This is when you've just got a random number hanging out in your code with absolutely no explanation. Sure, it works, but nobody, and I mean nobody, knows why it works. Just take a look at this function here. What on earth is 9.98? Is that shipping, a handling fee? And what about 0.10? Is that sales tax, a discount? Trust me, 6 months from now, even the person who wrote this will have no idea. And that is exactly why magic numbers are so dangerous. They completely destroy clarity. Okay, another classic anti-pattern is the God object. This happens when you create one single class, one part of your program that just tries to do everything. It becomes this massive, tangled beast that's impossible to understand, impossible to test, and you can't update it without breaking 10 other things. It's a real mess.
For instance, look at this ticket class. It's responsible for storing data, extracting data, and handling the purchase logic. By trying to be a jack of all trades, it becomes a master of none. The pro move here is to break this up into smaller, focused pieces that each have one and only one clear job.
So, how do we fight back against these anti-patterns? Well, one of the most powerful principles out there is DRY, don't repeat yourself. This slide shows that evolution perfectly. You might start out just copying and pasting code. A small improvement is to use a variable. That's better. Then you can wrap that logic up in a reusable function. Even better. And the final step, automate the whole thing with a loop. You see that progression? We've gone from messy, repetitive code to something that's clean, concise, and so much easier to maintain. This brings us to the final and, honestly, the most important evolution for a developer. It's a shift from just writing lines of code to understanding the entire system. This is the leap from junior to senior, and it is all about your mindset. A junior developer, their main focus is to write the code that completes a specific task. A senior developer thinks bigger. They're constantly asking questions like, how is this going to affect performance? How will this scale? Is this going to be easy for someone else to understand a year from now? They don't just see the one piece, they see the entire puzzle. And here is another huge shift. A junior developer is great at solving a problem once you give it to them. A senior developer, they step back and question the problem itself. They have the wisdom and experience to ask, wait a minute, is this feature even necessary? Is there a simpler solution we're totally overlooking? They're moving from just execution to actual strategy. And hey, this isn't just a feeling. We've got data to back it up. This study looked at what programming students find the most difficult. Just look at syntax. It's the lowest bar by far. The real challenge, the real struggle, comes with these high-level ideas like object-oriented concepts and design. Mastering syntax gets you in the door, but mastering design is how you win the game. And with that senior mindset comes the wisdom to avoid one final, very tempting mistake. The legendary computer scientist Donald Knuth famously warned us all that premature optimization is the root of all evil.
So what does that mean? It means you're trying to make your code super-duper efficient before you even know where the real slowdowns are. You can waste days, even weeks, optimizing a piece of code that was already totally fine, while the real performance killers are hiding somewhere else. A senior developer lives by this mantra. First, make it work, then make it right, and only then, if it's actually necessary, make it fast.
So, as we start to wrap this up, it becomes pretty clear that the path to becoming a great developer isn't about avoiding mistakes. It's about learning to make better and better mistakes over time. Your journey is going to follow this path. You start by mastering the basic rules of the language. Then, you learn to write code that isn't just functional, but is clean and clear. And finally, you gain that wisdom to think about the entire system, its architecture, its long-term impact. Each stage is built on the lessons you learned from the mistakes of the one before. You have to remember, every bug report, every crash, every time you get an unexpected result, it's a free lesson. It's a chance to sharpen your logic and build more resilient, more elegant code. So the real question isn't if you'll make another mistake, but what amazing breakthrough that mistake is going to teach you next.